Here are a few more examples of how to simplify exponential expressions when we have zero exponents or negative exponents. In the first one, you'll notice that the 5, even though we don't see it originally, it has its own positive exponent of 1. A also has a positive exponent, so the only one that has a negative exponent is this b to the negative second power, so that's the only one that's going to move to the opposite side. And once we move it, that 2 will become positive. So in its simplest form, we have 5a to the third over b squared. We don't know the value of a, we don't know the value of b, so at this moment, that is our answer. In this bottom one, we have 1 over x to the negative fifth. We don't have any zero exponents, but we do have a negative exponent. I'm going to put a 1 in front of it because we can always have a coefficient of 1. The only portion that's going to move is this x to the negative fifth. So that's going to give us 1 x to the positive fifth now over 1. And we don't have to show that we're dividing by 1. That we can simplify, because it's in the denominator. 1 is in the denominator. So it's really going to give us just 1 x to the fifth, which in this moment, we don't have to show that 1, because anything could be multiplied by 1. Even without it written, there's still a coefficient of 1. So we do a few more. A would become 1 over x to the positive ninth power. The only thing that moved was the x term. For this one, again, the only thing that's going to move is the n to the negative third, which is going to give us 1n to the positive third, which can just be written as n to the third. We don't need that coefficient of 1 in our final answer. You'll notice for this one, in the first example, we must keep 1 in the numerator. That's super important, because without it there, the x to the ninth would be in the numerator, and that would completely change the value from it being a fraction to a larger number. So 1 in the numerator we must keep, 1 in the denominator we can simplify away. In this example, we've got multiple terms. The 4 has its own positive exponent, same as the b, so the only one that is negative and going to move is the c to the negative third to the bottom, which will leave us with 4 times b all over c to the third. For d, similar process. We'll give that a to the negative third a positive 1 coefficient. That positive 1 will stay, but this a to the negative third will move to the top, giving us 2a to the third over 1. We don't need to keep the 1 in the denominator, so we just get 2a to the third power. Our final example has a negative exponent. So we're going to give that negative exponent term a 1 coefficient. And m to the second power, this one's positive, so that one's going to stay where it is. That one's negative, that one's going to move. But only the n to the negative fifth. The 1 also stays. So in the end, we get 1 over, we're going to put those variables in alphabetical order. So the m is going to go first, and we're going to have m squared times n now to the positive fifth power because it moved to the opposite side. And that is the answer. For just a few more practice problems of simplifying exponential expressions with zero and negative exponents.